So today we will be discussing about Newton's rings. So when a plano-convex lens of long focal length is placed on a plain glass plate, a thin air film is formed between the plates and the lens. You can see in the figure that we have a glass plate here in the bottom over which a plano-convex lens is kept. Plano-convex lens means one of the surfaces is spherical and the other surface is plane. So when the plano-convex lens is placed on the surface of this glass plate G, a thin air film is formed between the plano-convex lens and the glass plate. And the thickness of this air film varies from 0 at the point of contact to a value T. So at the point of contact, the thickness of the air film is 0 and it gradually increases to some value. And if the lens plate system is illuminated with a monochromatic light falling on it normally, concentric bright and dark interference rings are observed in the reflected light. These circular fringes are called Newton's rings. So in this apparatus, you can see in the figure, a horizontal beam of light falls on the glass plate B. A horizontal beam of light falls on the glass plate B, and this glass plate is kept at some 45-degree angle, and a part of the incident light reflects towards the air film enclosed by this lens and the plane glass. And the reflected beam from the air film is viewed with a microscope. Alternate dark and bright fringes are produced due to the interference between the reflected light from the lower surface of the lens and upper surface of the glass plate. So here, when the light is incident here, the reflected ray from the lower surface of the lens and upper surface of the glass plate come together and interfere, forming either bright fringe or dark fringe. And we know the condition of bright fringe is 2 mu t cos theta equals n plus half lambda. We have already discussed this in the case of reflection from thin films. And here we can see that all other parameters like mu, theta, lambda, all these parameters are constant except for T. T is the thickness here. So for this air film, the thickness at the center is 0, thickness is gradually increasing, so thickness is varying. So for a particular thickness, suppose I consider this section, and in this section suppose there is some thickness T1. So this thickness, so all the points in the film having same thickness T1 will form a fringe, and that will be in circular shape, which is why Newton's rings are in circular shape. So all the points having same thickness will belong to a particular fringe which is in circular shape. So now for small value of theta, theta is the angle of refraction, and for small value of theta, cos theta can be approximated to 1. And since it is air film, mu or the refractive index is 1. So this can be written as 2t equals n plus half times lambda, where n equals 0, 1, 2, 3, etc. So for dark rings, the condition will be 2 mu t cos theta equals n lambda, and since mu equals 1 for air film and cos theta approximately equal to 1, this can be simplified to 2t equals n lambda, where n is 0, 1, 2, 3, etc. So, and now assuming this spherical surface of the lens to be part of a larger sphere, and the radius of the sphere is taken as capital R, radius of the sphere is taken as capital R, and the distance OQ is taken as small r, and the thickness PQ is small t. HC can be written as, or CH can be written as, CH square equals HE square plus CE square from Pythagoras theorem. That is, CH square equals HE square plus CE square. Then HE is similar to BO, so BO square plus CE can be written as CO minus EO whole square. So CH is the radius of the sphere capital R. HE or BO is the distance small r. CO is the radius capital R, and EO is the thickness small t. So this can be further simplified to r square equals 2rt minus t square. Again, here thickness is very small, so we can assume, we can neglect the value t square. So small r square equals 2 capital R into t. So we can obtain the value of t from here. We have the equations or the conditions for bright rings and dark rings. So here, substituting the value of t, that is r small r square upon 2 capital R, to this term, so this becomes, so the condition of bright fringe was 2t equals n plus half lambda. So t is r square upon 2 capital R. So this becomes r square upon 2 into capital R. R changes with the order small n. So this can be Rn square. So finally, after simplification, we obtain Rn square equals n plus half lambda capital R. So Rn is the radius of the nth bright fringe. And again, using the condition of dark fringe, which is 2t equals n lambda, we can substitute the value of t here, and finally we obtain the radius of the dark fringe. Now we know n takes values 0, 1, 2, 3, etc. So for n equals 0, the radius of the dark ring is 0. This is the condition of dark ring, and this was the radius of the dark ring. And when n equals 0, radius is 0. That means the central ring is dark, while the radius of the bright ring is, when we substitute n equals 0, this becomes lambda r upon 2, root over lambda r upon 2. So the central ring is dark because its radius is 0. And now the diameter of the dark ring can be obtained by taking 2 times the radius. So 2 times n r root over n r lambda. Root over n r lambda times 2 gives the diameter of the dark ring. So for the central dark ring, we know the diameter is 0 since n equals 0. Thus we take the first dark ring as n equals 1, since n equals 0 gives 0 radius and it belongs to the central part of the Newton's rings. The diameter of the first dark ring will be 2 times root over r lambda. And for nth dark ring, this becomes dn equals 2 times root over n r lambda. Now, one thing to note here is that the diameter does not increase proportionally with the value n, because it is root over n. So as n increases 1 2 3 4 etc., diameter will be increasing like this, like 2 times root over lambda r, 2 times 1.4 which is root 2, again root 3 which is 1.7, root 4 which is 2. So this is not a uniform increase. This is, the rings gets closer and closer as n increases. So the rings, as the diameter increases, the rings get closer and closer, which is why the space between the rings are not even. Now Newton's rings by transmitted light can be obtained in the same manner. We just take the condition for transmitted light in the bright fringe and dark fringe, and the condition is given by 2 mu t cos theta equals n lambda. Doing the same, following the same steps, we obtain the value of t as n lambda upon 2. And from the previous case, that reflected light case, we had obtained small t equals small r square upon 2 capital R. So substituting the value of t in the condition for bright and dark rings, we obtain the radius of bright and dark fringe as this. This will be the radius of bright fringe and this is the radius of dark fringe. So for n equals 0, here this becomes root over half lambda r. But this value, that is the radius of bright fringe, becomes 0 for n equals 0, which means central fringe is a bright fringe. But in the reflected light case, central fringe was a dark fringe. This is the basic difference.